This is Algebra 2, Unit 2, Lesson 7 on systems of linear equations. Now, systems of equations we've done in Algebra 1 and we've done in geometry. And usually we have two equations and two unknown variables. Well, in Algebra 2, we actually bump it up to three equations and three unknown variables. But the method is basically the same when you do these. So we actually have two methods to solve a system of equations. We have substitution and we have elimination. So let's review how to do each one of these. I have the same equations right here. I'm going to solve this one by substitution, and I'm going to solve this one by elimination. So let's practice. All right, substitution. You need to get one of the equations, either x equals or y equals. Well, the second equation right here, we could get y equals really easily by subtracting the 2x. That would give me y equals negative 2x minus 7. And then since it's substitution, I'm going to take y equals here and plug it in there. So 3x plus 2 times negative 2x minus 7 equals negative 9. Distribute and solve, so that would be negative 4x minus 14 equals negative 9. Combine your terms, negative x minus 14 equals negative 9. Add the 14, negative x is equal to 5. Divide by negative 1, x is equal to negative 5. And make sure that you plug back in. Y is negative 2 times negative 5 minus 7. So that would be 10 minus 7, which is 3. So your x is negative 5, and your y is 3. And that is substitution. All right, now elimination is when you have the variables lined up with each other and you get one of them to cancel. Now, I have 3x and 2x, and I have 2y and y, and I want one of them to cancel. Remember, when you cancel, you need an additive inverse. So can I change one of these to make it an additive inverse pretty easily, or both of them? I can do either one. Well, the easier one in this one would be y. So if I take this equation, what would I have to multiply this by to get the 2y to cancel? Well, this would have to be negative 2, so I want to multiply this equation by negative 2. So I'm going to write my original equation, 3x plus 2y equals negative 9. Multiply through the second equation by negative 2. Negative 4x minus 2y equals 14. And then add down your columns. When you add down the columns, the y's cancel. That gives me negative x equals 5. Divide by negative 1. And x is equal to negative 5. So I got the same x that I had here. And when I plug in, it doesn't matter which one I plug into. I can plug into the first one or the second one. It doesn't matter. So I'm going to plug into the second one. 2 times negative 5 plus y is equal to negative 7. Negative 10 plus y equals negative 7. Move the 10 over, and y is going to equal 3. So I ended up with the answer of x equals negative 5 and y equals 3. Now that answer will work in both equations. If I substitute in either the first equation or the second equation, both of these equations will be true. So that's a quick review of substitution and elimination. All right, so what we're going to do is look at a 3x3 system of linear equations. 3x3 means you have three equations and three unknowns, x, y, z, and 1, 2, 3 equations. All right, now usually when you do a 3x3 system, you use elimination. All right, so what you want to do is create a system and eliminate the same variable each time. All right, so I have three equations here. I'm going to take two equations and use elimination to do that. All right, I'm going to take the first two equations. I have 2x plus y plus z is equal to 15. And I have 6x minus 3y minus z is equal to 35. All right, I want to eliminate a variable. Which would be the easiest variable to eliminate on this? Well, probably the z. You can see the z right here is going to cancel out if we add these down. So I'm going to add these together because I'm going to cancel these out. I get 8x minus 2y is equal to 15 plus 35 is 50. So I have 8x minus 2y equals 50. All right, now I'm going to take two other equations. I can pick any two I want. Well, since this is plus z, and I cancel the z on the second one, why don't I do minus z here and cancel the third one? So I'm going to take the first equation again, and I'm going to take equation number 3. Negative 4x plus 4y minus z is equal to negative 14. All right, my z's are going to cancel. That gives me negative 2x plus 5y equals 1. So now I have two equations where the z's canceled out. All I have left is the x's and y's. So now what I can do is take these two equations and cancel out another variable. So let me write them over each other. 8x minus 2y equals 50. Negative 2x plus 5y is equal to 1. Okay, now you have to decide which variable you want to cancel. We canceled the z's already. Now we either have to cancel the x's or the y's. It's up to you. I think I'm going to cancel the x's. Because this is 8x and this is negative 2x, if I multiply this one by 4, that will get this to be negative 8x. It'll cancel out. So 8x minus 2y equals 50. Multiply the second equation by 4, I get negative 8x plus 20y is equal to 4. Add down your columns, the x's cancel. Negative 2 plus 20 is 18y is equal to 54. And divide by 18, and y is equal to 3. So now that I know y is equal to 3, I can plug back in to my other equations to find x and to find z. All right, so if I go back to one of these two, it doesn't matter which one. I'm going to use this one right here. Negative 2x. I just found what y is 3. So negative 2x plus 5 times 3 is equal to 1. Negative 2x plus 15 is equal to 1. Negative 2x is equal to negative 14 when I move the 15 over. Divide by negative 2, and x is equal to 7. So x is 7. Y is 3. I know what x and y are now, so now I can find z. So I can go back to here and pick any of those three equations and plug them in. All right, I'm going to pick the first one. 2x, which would be 2 times 7, plus y, which is 3, plus z is equal to 15. 14 plus 3 plus z is equal to 15, which would be 17, plus z is equal to 15. And then subtract the 17, and you get z is equal to negative 2. So I just found x, y, and z by using elimination. All right, now I'm going to use my calculator and the store function to check my values. All right, so what I want to do is I want to store my values of x, y, and z. So I want x to be 7. So I press 7, the store key down here, and then x. Enter. So now my x's are 7. For my y is 3. So I put in 3, store. Now you can see in green up here on the 1 key, that means you have to use the alpha key to get y. Enter. And then z is negative 2. So negative 2, store, alpha, and that's number 2. So x, y, and z actually all together right here. So now my x, y, and z are 7, 3, and negative 2. So if I enter my equation, 2x plus y plus z equals 15. All right, 2x plus alpha y plus alpha 2 to get z, 2x plus y plus z, that should equal 15. Let's see if it does. Yep, that's right. Okay, the second one is 6x minus 3y plus minus z. 6x minus 3 alpha y minus z alpha 2 is equal to 35. Yep, that worked. And the third one, negative 4x plus 4 alpha y minus z alpha 2 should equal negative 14. Yep, it worked. Okay, now the only thing about the star key, those values of x, y, and z will stay those values of x, y, and z until you change them to something else. So this is a good way for you to check to make sure your system is correct. All right, now let's try solving another one. You don't always have to eliminate x, y, or z all the time. It's the one that makes the most sense to you. So if we're looking at this problem, 4x plus y minus 3z equals negative 6, negative 2x plus 4y plus 2z equals 38, 5x minus y minus 7z equals negative 19. We have to decide which one would be the easiest to eliminate, x, y, or z. Well, let's look at the values. This is 4, negative 2, and 5. Not a whole lot of x's that have in common. But y, 4y, and negative y have a couple that would be pretty easy to eliminate. 3, 2, and 7, you'd have to do a lot of multiplying there. So probably the y would be the best one. So we're going to take the first two, and we are going to eliminate the y. So 4x plus y minus 3z is equal to negative 6. Negative 2x plus 4y plus 2z is equal to 38. Okay, so if I'm going to eliminate the y, and I'm going to cancel out the y, this would have to be what? Well, this would have to be negative 4y. So I'm going to multiply this by negative 4. Make sure you multiply all your values. Negative 16x, negative 4y, plus 12z is equal to 24. So that's my first equation. Then my second equation, negative 2x plus 4y plus 2z is equal to 38. All right, add down your columns, the y's cancel. So this is going to be negative 18x plus 14z is equal to 62. There's my values. Yep. Okay, now since I'm eliminating the y in this equation, I'm going to eliminate y in my other two equations. So I need to pick two equations to use. What two would be good to use? Well, I have to use the third one because I haven't used it yet. Which one would go best with that? Well, probably the first one because that's plus y. So let's do that. 4x plus y minus 3z equals negative 6. And then I'm going to use this third equation. 5x minus y minus 7z is equal to negative 19. All right, add down your columns. The y's will cancel out. That gives me 9x minus 10z equals negative 25. All right, so now I have my y's eliminated. I just have x's and z's. All right, so my 2 by 2 will be negative 18x plus 14z is equal to 62. 9x minus 10z equals negative 25. All right, now I have to decide which variable I want to cancel now. Well, I can cancel the 18 and the 9, or I can cancel the 14 and the 10. Well, probably the 18 and the 9 would be easier, because all I'd have to do is multiply this one by 2 to get it to cancel out. So the first one stays as it is. And the second one multiplied by 2, make sure you multiply all of them. And then that'll be negative 50. Add down your columns, the x's cancel, and all I'm left with is z's. Add the z's down, you get negative 6z is equal to negative 12. And divide by negative 6, z is equal to negative 2. So now I know z is negative 2. I can plug back into either of the equations and find it. So I'm going to pick this one. 9x minus 10 times negative 2 equals negative 25. 9x plus 20 equals negative 25. Subtract the 20. 9x is equal to negative 45. And x will equal negative 5. So there's my x. Now I know x and z. I can plug into either of these three and find y. So I have 4 times negative 5. I'm going to use the first one. Plus y plus negative 2 is equal to negative 6. Negative 20 plus y plus negative 2 equals negative 6. Y minus 22 equals negative 6. Add the 22, y is equal to 16. So there are my values of, sorry, that's wrong. Yeah, I left off my 3 here. It should be minus 3z. Make sure you're accurate on this. It's very easy to goof it up. 3 times negative 2, which would be positive 6. There we go. So negative 20 plus 6 is negative 14. And then added the negative 14 to the negative 6, and you get y equals 8. All right, so if I'd gone back and checked each of these values, I would have found that. All right, so that is the systems of 3 by 3 system of equations. See if you can solve exercise 4. We'll go over it in class tomorrow.